In our previous video, we discussed how to get the maximum benefit from question practice. We talked about the idea of making reviews in theory, but when you actually sit down to do it, it can feel overwhelming, confusing, and sometimes even misleading. So today, let's look at how to write a review properly, in a way that helps you. Revise the theory you already know, learn new information hidden inside the question, practice question approaching techniques, identify the correct answer in minimum time, and most importantly, make sure you can score a similar question the next time it appears. Now, one small disclaimer, this review method is my personal approach, and I am writing it as if I were a beginner high school student. For teaching purposes, I'll customize it in a way that a wider audience can follow. Your own review style can be smaller, bigger, simpler, or completely different, and that is perfectly fine. Let's take an example question. As you move down any group in the periodic table, A, the elements all become more reactive. B, the core charge will increase. C, the ionization energy decreases. D, the electronegativity increases. First, read the question carefully. As you move down any group in the periodic table, before even looking at the answers, understand the scenario. This is a periodic trends question, specifically asking about what happens down a group in the periodic table. In your exams, you will be provided with a periodic table, so train yourself to immediately visualize the movement being discussed. Now quickly scan the answer choices. What changes are they talking about? Reactivity, core charge, ionization energy, electronegativity, good. Now we know what we are testing. Second step, understand the type of question. What kind of question is this? This is a property comparison question. We are checking what happens to different properties as we move down a group. So what is the best strategy? We go option by option, testing whether each statement is universally true. Let's start. Option A, the elements all become more reactive. What is reactivity? Very simply, reactivity depends on how electrons behave. The easier an element can lose or gain electrons during interactions, the more reactive it is. Let's think about group 1 elements. They react by losing their single outer electron. As we move down the group, more electron shells are added, atomic size increases, shielding increases, effective nuclear attraction on the valence electron decreases, so that outer electron becomes easier to remove, meaning group 1 reactivity increases down the group. Sounds correct so far, but wait. The statement says, all elements become more reactive. All, is that universally true? Let's test another group. Group 17 elements react by gaining an electron to complete the octet. As we move down the group, atomic size increases, shielding increases, effective nuclear attraction decreases. Now the atom becomes less able to attract a foreign electron, meaning Group 17 reactivity decreases down the group. So option A is not universally true. It is partly correct and partly wrong. In chemistry, half correct is still wrong. Let's continue. Option B, the core charge will increase. What is core charge? In simple terms, it refers to the effective nuclear attraction felt by valence electrons. So what happens down the group? What happens to the nucleus? More protons are added, so yes, nuclear charge increases. Trangiu. What happens to electron shells? Each new period adds a new electron shell. So as we move down, more shells are added, shielding increases, electron repulsions increase. Even though the nucleus becomes more positive, the outer electrons are much farther away and more shielded. As a result, valence electrons actually feel less effective attraction. This is also why atomic size increases down the group, so effective nuclear attraction, or core charge felt by valence electrons, actually decreases. Therefore, option B is incorrect. Option C, the ionization energy decreases. What is ionization energy? Very simply, it is the energy needed to remove an electron from a neutral gaseous atom. Usually, when someone says ionization energy without specifying, we mean the first ionization energy. Now think back to what we discussed in option B. Down the group, valence electrons experience less attraction to the nucleus They are farther away. Shielding is greater. So what happens? Those electrons become easier to remove. And if something is easier to remove, we need less energy, meaning ionization energy decreases down the group. This statement is 100% correct. We probably found our answer, but never stop immediately after finding the correct answer. And this is important. In exams, always check the remaining options and confirm your choice. Double-checking saves marks. Let's continue. Option D. The electronegativity increases. What is electronegativity? Electronegativity is the ability of an atom in a bond to attract bonding electrons toward itself. So, highly electronegative atoms should have strong nuclear attraction, smaller atomic size, stronger pull on electrons. Does that happen down a group? No. Why? Because we already discussed more electron shells, more shielding, weaker effective nuclear attraction, larger atomic size. Therefore, atoms become less able to attract bonding electrons, meaning electronegativity decreases down the group, not increases. In fact, highly electronegative elements are usually found toward the top right of the periodic table, so option D is incorrect. Final answer, C. The ionization energy decreases. So that is an example of effective review making. Notice what we did here. We didn't just find the answer. We revised theory, learned periodic trends, compared groups, understood why wrong answers are wrong, and practiced how to approach the question strategically. And this method can be applied to every chemistry question type. Yes, every question. In fact, if you've been following our question discussions, you may have already noticed that we quietly follow this exact review method to help students maximize both understanding and exam performance. We'll be discussing more question approaching strategies in future videos. Also, don't forget to subscribe to our newsletter, where every Friday we break down more exam questions using this same format. And check out our landing page to explore our other services. See you in the next one. Yours, Atom Academy.